Oh, there we go. Holy mother of all God. What have I gotten myself into? Hi YouTube. I am going to attempt to fit this into frame. This is a teardown / dissection and reverse engineering jump start on the Bren-Tronics vehicle mounted charger PP-8481B/U. This is a very large, as it says on the box, vehicle mounted charger intended to mount into a typically like a Humvee or something, and they are used to charge up military equipment batteries, such as this BB-2590 lithium battery. And the idea is that this is a durable, rugged, weatherproof metal box that you can mount into your vehicle. If the batteries catch fire, they're not going to be able to set anything else on fire, such as, I don't know, ammunition that you would find inside a vehicle-mounted charger. Or not inside the charger, but around the charger. It's also versatile in the fact that it can be powered off of 120 volts AC and or 24 volts DC, depending on the cable that you use to plug it in. Everything is labeled both right side up and upside down, so that no matter which way the charger is oriented, you can read and figure out what's going on, and they put extra labels so that if some of the labels get damaged by things being set on top of them, you can still figure out how to operate the device. They tend to idiot-proof things a lot in the military. So on the top we have this ginormous lid. This thing's about 40 pounds. We've got a clear, I think this is glass, possibly Lexan or polycarbonate. It's a window to look at the indicator LEDs to see which battery is charging. On the back we've got our mounting brackets, and this thing does come with mounting hardware. Some of the brackets are a little warped. That's fine. I'm not going to be mounting this, I'm going to be using this indoors. And the hope is that I can reverse engineer this sucker to charge other types of lithium batteries, such as Anton Bauer Gold Mount batteries or Sony camera batteries, or anything that I really want. I just have to see how I can take control of it, if it's possible. Let's bring up the other camera. On this side we've got the charging, not the charging port, the power connector port. It's 5 pins, and it takes either 110 volts AC, so you'd have, of these 5 pins, 3 would be live, neutral, and ground, and then the other 2 would be plus and minus, or positive and ground, 24 volts DC. Humvees and everything else in the military seems to standardize on 24 volts, so that's why this uses 24 volts, and you can't just use 12 volts. Alright, let's bring up the other camera. On the front, if I can get this on the workbench without dropping it on myself, you can get an idea of just how big this thing is. We've got a intact label, and again it's mounted or labeled right side up and upside down. We've got these really nice heavy duty butterfly style latches, and this very big, robust, what appears to be either cast aluminum or magnesium, and it's very hard. It's not, it doesn't feel like an aluminum, it feels like a magnesium in terms of its hardness. There's a small chip out of this corner. I'll have to see if I can set fire to it in a controlled condition. I don't know if I'm going to be able to, but we'll see. But this side is a heatsink, and on the reverse of this plate appears to be the charging circuitry itself. Let's put this thing right side up and look inside. Alright, so let's crack this sucker open. Alright, I can't even see over the monitor. My witness monitor is in front of me, but it's behind all of this stuff. So I've already gone ahead and taken out one of these modules. This is a battery adapter unit. It looks something like this. There's already one down here with pin connectors, more like spade connectors on the bottom, with a polarization pin to make sure that you put it in the correct way, a screw down retention point here where you can tighten a screw or loosen it and remove the adapter. And there's that loose chunk of heatsink that I was mentioning. You just grab these two handles and pull up to free the unit. Now, the reason why you have the two adapters is so that you can swap them out. You can have different types of radio batteries or different types of batteries for your night vision optics or thermal optics or anything else under the sun that you can think of. Up to and including like a big bank of AA batteries. I'll see if I can find some pictures and put them over top, but there are quite a few different adapters for this. And my rationale was, when I looked at the pictures, you've got all these different pins, and you've got all these different battery types that it services. You've got 7 different types of batteries on here, or well, six different types of batteries, some of which are supported twice. Of these different batteries, how do they actually get controlled? How are they monitored through these multi-pin connectors? What could be done to kind of co-opt it? That's the idea anyway. On this inside lid, there's an adapter A and adapter B here. So it actually tells you on the, shift this over a little, she tells you adapter A, adapter B, and this position is adapter B, this position is adapter A, and you can actually swap out which side is which. And it cycles through the different batteries until it's serviced all of the batteries. So I'll have to reverse engineer the circuitry of the battery adapters, but there are some relays clicking on and off, so I suspect that it does some sort of a series relay scheme in order to select one of the 8 batteries at a time to charge per slot. On this side, we've got a RS-232 port to, I guess, connect a serial connector of some sort, probably a DB9. We've got a power switch, AC and a DC circuit breaker, and actually, you know what I will do is I will plug in this unit and power it up just so you can see what it does when you cycle it on. Alright, so I've gone ahead and hooked up the power, and we are going to power on. It's gonna go through a bunch of self-checks. You can hear actually quite a few different relays clicking inside here. But now that this thing's powered up, it's cycling through batteries attempting to find one to charge. I'm going to actually hook up one of these BB-2590 batteries. And you'll notice that it's not bothering to check... oh, that's interesting. I guess this label is backwards. It's only checking position B, which I guess is on this side, and is not bothering to check anything on position A because there's no adapter loaded. So we're going to plug this guy in. And it's found the battery. And rapid flashing is charge pre-qualification, according to the chart on this side. So it's evaluating the battery and seeing what to do with it. Solid on is fast charge. So that's it in a nutshell. You do have a couple more indicators. You've got a power LED, a temperature fault, and a low vehicle power LED, as well as this blackout button. You press that blackout button, it turns off all the LEDs. It seems a little silly, but if you are operating in zero light conditions with night optics, the last thing you want is one stray LED to foul your, I guess, auto gain on your night optics. And if you don't have night optics, you don't want any light to ruin your night vision. You want to see everything possible. But yeah, it's relatively easy to just turn that back on. Anyways, don't need to charge this battery up. We're going to take that out. And it's immediately gone back into its search mode to try and find another battery to charge. That's it for this side. I'm just going to power this off, pull the power cable, and we're going to take a look under this cover here. So I've disconnected the power, and let's dive a little deeper. Before I go a little deeper, let's just take a quick look at this lid for just a second. Is this the construction quality? You got some sort of an EVA type foam on the lid to keep the batteries from rattling around. Then you've got this very heavy duty 3/8 inch thick rubber gasket, which seals very tight against this lid. There is a slight indentation from the kind of permanent closing nature of this. Then you've got this window. It does feel like it's plastic, it doesn't feel like it's glass, but presumably it's rated to some degree of fire retardance to contain any sort of battery failures in here. And my assumption would be that the US military highly qualifies their batteries to make sure that they don't inadvertently catch fire, because that would be bad. Alright, so on the inside, unfortunately I can't show you with the camera, there is a grate or a screen here. I'm going to give this a little bit of a wipe down just because it's really dirty and nasty. Alright, let's just take a quick peek underneath this RS-232 port. The construction quality on this so far is very robust, to say the least. Let's take that out of the way so we don't lose it into the guts of this thing. And below the port we have no fancy gasket. Just an RS-232 DB9 connector port. Nothing more special than that, it seems. Let's just set that out of the way, though. Now, as soon as I undid this screw and this screw, the panel sprung up. It appears that there's some sort of a gasket or conformal spring. I'm not sure if it's a an RF shielding to minimize electrical noise to other equipment kind of consideration, or a weatherproofing consideration, because the outer gasket on the lid should take care of any water or weather ingress on this unit. So in theory, you shouldn't even have to put a secondary weather seal. Plus, there's an open air grill over here, so it really shouldn't need additional weather sealing. But let's peek under the cover. Door number one. It would appear zip-tied wiring harnesses. I cannot free that up at all. Yeah, I think I'm gonna have to come back to this one. Oh! Ha! Now that's funny. They give you two different plates, a right side up and an upside down. And they're different plates too, because the cutout for this power switch is designed to go around that nut. And these inset circuit breakers won't inset into this panel. So it's designed to have two panels from the outset. One to go on top of the other, so that you can have a right side up or an upside down. That is incredible. They think of everything, but also just the extra costs associated with each of these parts to have to maintain stock of these parts. I am, however, going to put some of these screws back in because I can't get at that from this side. I suspect I'm going to have to come at this from the underside, disconnect some cables to free it up, and then we'll be able to remove that top panel and take a look. Alright, I've gone ahead and repositioned this in this orientation. Before I go too much further, however, I'm going to get curious, and I want to know what the mounting torque is for these screws before I back them out. So to do that, I'm actually going to be a little sneaky here. I'm going to use my torque screwdriver, and I'm going to start at 7 inch-pounds. The theory is, if this torque screwdriver is set higher than the torque on the base, then it won't click. But if the torque is higher on the screws, then it will click. 11 inch-pounds. This only goes up to 11.5. Yeah. Well, some of these aren't torqued all the way to 11. But it looks like 11 inch-pounds isn't a bad number to go to, because some of these fasteners are quite tight. Yeah, plus there's a rubber gasket that gets compressed, so when I take this apart I'm going to break that rubber seal, and it's only going to get looser. So any extra pressure I can apply with the fasteners should help. Use some pretty big fasteners, and they come with little nylock patches. Last screw head. Let's see what's behind door number 1. Might need a little bit of mechanical assistance. Oh, there we go. Holy mother of all God. What have I gotten myself into? This is a not at all compact, lightweight arrangement. I wish I could show you with the camera from this angle. Suffice it to say, I'm going to be snipping a lot of zip ties. There's no easy way for this whole assembly to just come right off, but I'm going to start disconnecting ribbon cables. What do we got? We have a universal power supply, 110 to 240 AC, 47 to 63 hertz, 5 amp max, output 22 to 30 volts at 13 amps, 300 watts. Preset to 27 volts. We'll have to see if it's actually that voltage. Shoot. The lid is closed, the power switch is up here. I can't actually power this on. I had to snip one zip tie already to get this cable free. And then on this side we have what looks like some kind of a custom DC-DC converter combined with okay, this is a whole complicated mess. You've got current sense, you've got switch mode power supply functionality in the inductors, you've got another current sense, you've got multiple connectors, you've got a 10-pin, you've got a 4-pin power cable, you've got a 2-pin power cable, you've got this ginormous IDC ribbon cable connection. You've got a whole bunch of different transistors, a TO247, bunch of TO220s, another TO247. So you've got a whole bunch of power conversion going on this board, and it's custom, Brentronics. Everything's conformal coded on the board. All the capacitors and larger components are hot glued into place. You've got test points on here as well, presumably because something of this magnitude, if something fails, they would just send it back to the factory to get fixed. But for now, I think what I'm going to do is disconnect this power supply and take this entire board assembly and set it aside. But I guess this is where a good chunk of heat dissipation occurs, given that this is one gigantic heatsink. This might be aluminum after all. just given the inside surface finish. And actually, I'm going to take a picture real quick of the wiring configuration, just so I remember how this thing goes back together. Definitely kudos for details here. The protective earth, there's multiple screw heads. Or not multiple screw heads. There's the chassis protective earth, because remember, this entire heatsink sits on this gasket. You can't rely on the screws to provide a fault current path from the chassis to the heatsink surface. So they've put a protective earth connection on the power supply, on the heatsink plate itself, and it's in 2 different spots. So they're pretty serious about that. We'll just disconnect this ever so carefully. Also, just taking a moment to appreciate the caliber of wiring here. I don't know what polymer this is, but I think this is a fluorinated polymer, because I've seen these before on aircraft type builds. Very high quality wiring harness here, spared no expense. They use full ring terminals, not spade terminals, it seems. So there is 0% chance. Oh no, this is a spade terminal. It's just a very small spade terminal. I don't know if the camera can see that, but it is a microscopic size spade terminal. And the spade is very forced on there. Alright, that's the AC power connection. And DC connection. Looks like you've got voltage output plus, voltage output minus, with multiple screw terminals for positive and negative, and then you've got a fan plus minus connection, a vis plus minus, an RTN, inhibit, and PG. I'll have to read the data sheet on this to see what those mean, and I'll maybe cut it in here. Alright, this thing is now free. So let's take this out and set this aside. Okay, this is a lot more complicated than I thought. What do we have here? We have a very robust mainboard plane here. And I'm trying to figure out how it mounts. It almost looks like it has rivet fitted metal inserts, and these metal fitted inserts are actually part of the PCB, so the screws from the top of the case thread down into the PCB itself, as well as the connector itself. For each of the 4 connectors are fastened by screws. You've got this 6-pin cable, which went to that that converter, which all on its own seems to do something. You've got this 4-pin, which goes to 2 power resistors in the bottom. They are 25 watt, 100 ohm. They're identical. So you've got 2 100 ohm 25 watt power transistors, which I suppose are for balancing and discharge, or they act as a current limit, act in a current limiting function. What else do we have down here? We have what appears to be some sort of DC to DC conversion board. I think that's what this board does. This is also branded Bren-Tronics. Let me bring the camera in. But what do we have here? We have this coming from the power supply, which if you trace it goes back to some of these in the back. Let's bring out the multimeter, see if we can't figure out where it goes. Bust out the old fluke. Got the negative terminal from the power supply, which may actually be common between these two. Yeah, okay, so the negative is common. We'll figure out where the positive goes. Alright, so we have 24 or something volt input from the AC power supply, and then what looks like DC power wiring coming from the connector going up into the cavity where the control panel is, and that control panel has a circuit breaker on it. Yeah, that control panel is very, very well connected up there. I would have to pretty much tear out the entire wiring harness on the side here in order to show you the underside of that board, and honestly, I'm not that curious. What is interesting, however, is there's a DB9 cable somewhere in here that goes to this board for RS-232 for firmware updates. Presumably that also means that the microcontroller for this unit is in the main board underneath the battery adapter plates. Coming out of this board, so I guess these terminals are DC input, these terminals are DC from the AC power supply. This connector appears to go to the power switch. So the power switch, even though it looks like a really big beefy toggle, I guess only enables this DC to DC converter. I'm very curious to see what the voltage coming out of this unit is. And where would that go? Interesting. Okay, so the that 2-pin cable, this one here, going to that converter board, which I suppose is where all the charge control, current control, voltage control happens, just takes a DC directly from here. We've also got a fan over here. It appears to be a, is it a 24 volt? It's hard to tell. I'd have to unmount it, and I really don't want to just because it's a lot of effort. But it does not look like it's a slouch either. It's a really big fan, and it seems to circulate air in a particular pattern. Let me reset the camera here. Alright, so we have our power coming from our AC power supply into our DC conversion board. We've got power from the DC conversion board regardless of vehicle power, 24 volts, or the power supply from AC shore power coming out to this connector through this conversion board. And my assumption would be that this board handles all of the, for lack of a better term, power cleanup. Because in a vehicle, when you turn the vehicle over, when you turn the key in the ignition, or I guess in a Humvee, press the start button, the voltage is going to significantly drop. You're going to have spikes. You're going to have a lot of electrical noise. So this board probably cleans it all up into a very clean DC power source here. Now, of these different cables, you've got the large cable, which probably handles all the current and voltage. Actually, no, it would be the data connections. You've got a ribbon cable, which is interesting. But the ribbon cable is interesting not because it's a ribbon cable, but because you've got the 8-pin cable here going through here and then continuing on over to the input DC converter. So presumably the control board itself can monitor the state of this unit, can monitor the state of the charge control board, and feeds all the information back up to here. This is a very complicated integrated charger. I thought this would be simpler. This would be a massive undertaking to reverse engineer, and I may not be able to reverse engineer it enough. But okay. Short of doing a super complete teardown, which appears to be, I wouldn't say impossible, but impractical, because some of these are riveted together, I think. I would have to settle with going as far as this. I'm just really fascinated by the transformer arrangement here as well. You got this transformer, you got an automotive relay. This is a plain old automotive relay strapped in here, so if this part burns out, and presumably it burns out enough that they make it field replaceable, and my focus is drifting a little. This common automotive relay, they could yank and scrounge that from the field if they really needed to. Yeah, this is just going to be a DC conversion board. You've got a little thermistor up here, which senses the air cavity temperature, and it looks like there's an air vent here, and there's an air vent here, and this fan pulls air and circulates it likely in this direction, or the other direction, but it still circulates the air through the battery compartment. I don't know if there's very much more I can do without doing a complete and total teardown of this upper board. So if there are enough people interested, I might actually try and dive into that, but it's a very tightly integrated unit. There's no messing about with this one. Alright, you know what, let's go take a look at the heatsink module in more detail. I'm going to be right back and grab that.